This is the walkthrough for Homework 12. Homework 12 deals with a topic called ANOVA. And ANOVA is an acronym for Analysis of Variance. And an analysis of variance is used when you want to see if two or more means are equal. And we've already checked to see if two means are equal, but if you want to check to see if more than two means are equal, then we do something called an ANOVA. So for instance, if you wanted to see if the number of, we'll see an example here in a little bit. The example that they use is the average number of students who play sports in 9th grade, 10th grade, 11th grade, and 12th grade equal? Or do more sophomores play sports than juniors? So I don't know, to answer those kind of questions, if you got more than two groups, in that case we had 4 groups, you do something called an ANOVA test. So let's walk through the homework and see if we can get a better picture of what an ANOVA is. And in the homework we'll have 2 different types of an ANOVA, a one-way ANOVA and a two-way ANOVA. So let's get going and we'll see the difference between the two. Problem 1. State the null and alternative hypothesis for a one-way ANOVA test. Which hypotheses below are for a one-way ANOVA? So in ANOVA, you assume that the groups have an equal mean. So remember the null hypothesis, that's like the status quo, right? Null hypothesis, nothing to see, everything's equal. No, nothing out of the ordinary happening here. So we assume that all the population means are equal. And the alternative would be that at least one is different. So that would be A. Number 2. Number 2 says this. Describe the hypothesis for a two-way ANOVA. Now on a two-way ANOVA, what we do is we think that there are 2 different effects that make some sort of reaction to the third thing. So in our example that we'll see in our homework, we think that maybe if we're doing a commercial, maybe the length of the commercial might have an effect. So will a 30-second commercial be as effective as a 1-minute commercial? Or will the type of commercial be effective? So that might look like TV versus radio. So you want to see if those 2 things have an effect. So you assume that they are equal, but then you want to see if there's an interaction between the 2. So you have 2 hypothesis for each effect, but then you'll have 1 more for the interaction. So that's a total of 3 hypotheses. A two-way ANOVA has 3 null hypotheses, 1 for each main effect and 1 for the interaction. In my case, that's B. You'll have a total of 3 null hypotheses, 1 for each effect, and then 1 for the interaction. Here comes number 3. Number 3, we actually do a problem. This is the one I was talking about earlier for a one-way ANOVA. It says this. The table to the right shows the number of female students who play sports on a sports team in grades 9 through 12 for a random sample of 6 high schools in the state. At the alpha value 0.05, can you reject the claim, let's see what the claim is, reject the claim that the mean number of female students who played on a sports team are equal? So the claim is that they are equal. Perform a one-way ANOVA test by completing parts A through D. Okay, here comes A. State the null and alternative hypothesis. Remember the null hypothesis, the status quo. You assume that they are equal. And that's what the claim was too. So the null hypothesis is that they are equal, and make sure that that is the claim. So in my case, there's the null hypothesis that they are equal, and that is the claim. For me, that's C. Yours will be different. Okay, next on B. What are the degrees of freedom? So the degrees of freedom for the numerator is the number of groups minus 1. So in this case, we have 4 groups, 1, 2, 3, 4, 9th grade, 10th grade, 11th grade, 12th grade, minus 1. So 4 minus 1 is 3. That's the number of groups minus 1. In fancy terms, that's called k minus 1, where k is the number of groups. So you take the number of groups minus 1 for the degrees of freedom of the numerator. The degrees of freedom for the denominator, what you do is you take the number of high schools that were sampled, and so that's the number of samples in the groups. In this case, we had 6 high schools, and they gave data on each grade. So we have 6 9th grade, 6 10th grade, 6 11th grade, and 6 12th grade samples. 6 plus 6 plus 6 plus 6, that's 24. So you take that number. So how did I get 24? Is I added 1, 2, 3, 4, 5, 6 for the 9th grade, 6 for the 10th grade, 6 for the 11th. I added all those together and I got 24. The degrees of freedom for the denominator is that total number, in my case it's 24, minus the number of groups. So in this case, we have 4 groups. 24 minus 4 is 20. So that's the degrees of freedom for the denominator. Okay, so just to kind of recap that, the degrees of freedom for the numerator is the number of groups minus 1. That's sometimes called k minus 1. The degrees of freedom for the denominator was that sample size, right? In this case, we had 6 for each group, and 6 times 4 was 24, minus the number of groups. 24 minus 4 was 20. So that's how we got our degrees of freedom to be 3 and 20. Okay, so let's see. How do you find a critical value? Well, we could go to a critical value table, but I want to show you how to do it maybe a little bit different. So what I'm going to do to find the critical value is you could look at a critical value table, and you could Google search critical value table for ANOVA, and you could get there, right? But what I want to do is I want to find it in StatCrunch. And in StatCrunch, so let me just upload my data into StatCrunch because we're going to need it anyways. Once you get the data uploaded into StatCrunch, to get the critical value, we're going to actually use a calculator. So if you go to Stat, Calculator, and then this is going to be the F statistic. So if you hit F, what we're going to do is we're going to put our degrees of freedom for our numerator. Remember, that was 3. Degrees of freedom for our denominator, that was 20. And then what we're going to do is we're going to make sure that you put the probability to be a greater than symbol. Okay? Change the probability to a greater than symbol, and then I want you to change it over here to be the alpha value. So we want it to be 0.01. That was our alpha value. And then we'll hit go, and that will tell us, so it says that P has to be greater than 4.9, I think they went to 2 decimal places, 4.94 if you round that value. So again, how did I do that for the critical value? For the critical F value, what did we do is we went to StatCrunch, and after we went to StatCrunch, we went to calculators. No, I think we went to Stat. I can make an S out of that. Stat, oh goodness. Guess I'll just have to start over. Here we go. We went to StatCrunch, and then we went to Stat, and then we went to calculators, and then we went to the F calculator, and then we put in our degrees of freedom for our numerator, degrees of freedom for our denominator, and then they ask for the probability. Make sure that the probability is that it is greater than or equal to X. Okay, and then what you're going to do is you're going to type in the alpha value right there. You're going to have to put in that alpha value. For my alpha value is 0.01, and then that will give you the critical value. Once you hit Once you hit compute, that will give you the critical value. Okay, so that gave me my critical value. My critical value was 4.94. 4.94. Okay. What did I do wrong there? 3 degrees of freedom. $20 for the denominator. Critical value, rounded to 2 decimal places, 4.94. Let's check the alpha value. My alpha value got me. My alpha value is 5%, not 1%. That's okay, I can change that. My alpha value is 5%, and that just makes it 3.098, so 3.10. If it's 5%, 0.05, then would be 3.10. 3.10. Okay. Alpha value got me on that one. Okay. Good deal. So where's the rejection region? Let me show you. Here's what the F curve looks like. It doesn't look like a normal curve. It kind of looks like a chi-square curve a little bit. It kind of looks like that. And remember, you reject on the tails, right? So this is the reject region on the tail. Reject the null hypothesis, okay? And you will reject the null hypothesis anytime it is greater than the critical value. So my critical value is 3.10. So we will reject anytime our F statistic is greater than 3.10. Okay, so let's see if that answers the question. We will reject if X is greater than, because that's out on the tail, right? Greater than or equal to 3.10. 3.10. Maybe strictly greater than 3.10. Okay. So it has to be strictly greater than 3.10. Not greater than or equal to. Okay, calculate the test statistic. All right, so how do you find the test statistic? Is make sure your data is loaded in StatCrunch. I got my data loaded. We will go to Stat. We won't go to Calculator, but instead we will go to ANOVA. We went to Calculator for our critical value. Now they want the test statistic. This is from ANOVA. This is a one-way. Our columns were 9th, 10th, 11th, and 12th graders. And I think that's it. I think we're ready to compute that. That gives me my F statistic. So out of all of this stuff, what I'm really worried about is the F statistic. So down there at the bottom, it says F stat, and that gives me 0.6362. 6362. 6362. Let's see. .6362, and you can see that is not in the reject region. So we will fail to reject the null hypothesis. We'll talk about that in a second, but first let's give StatCrunch what they, or MyLabs what they want. 3 decimal places. 0.636. Okay. What did we do? We failed to reject the null hypothesis. Remember, the null hypothesis is that all of those grades had an equal amount of people that played sports. We did not reject that. There's not enough evidence to say that there's any difference between 9th, 10th, 11th, and 12th grade female students that play sports. So what do? We failed to reject. Okay, let's continue. All right, well, let's see. Remember what the claim was. The claim is that they are equal, right? So there is enough evidence at the 5% significance level to support the claim that the mean number of female students who played on a sports team is the same for all grades. That was the claim. The claim is that they were the same. I guess another way to say it is there's not enough evidence to dispute that. All right. So you can learn from my little fumble there. There's not enough evidence to dispute that claim. Okay, last one. This last one's kind of a doozy. So I'll go ahead and just kind of finish this off. You know what? I'm thinking I'm going to do a new video. So I'll see you in the next video.